This is 1-6, solving for a variable. We have a couple of vocab words here. A literal equation is a formula or equation with several variables in it. You might use these in science class often, so this is going to be helpful for you guys in the future. A formula is an equation that states a rule for a relationship among quantities. We have some steps here for solving the variable, and so we're going to go ahead and try it for example 1. It says the largest yo-yo in the world is 32.7 feet in circumference. Let me highlight that. The formula for the circumference of a circle is C equals 2 pi r, where C represents circumference and r represents radius. Now it says to solve the formula for r, so let's rewrite this. C equals 2 pi r. So like we've been doing in the other sections, I've been highlighting the variable that I'm solving for. So if I'm solving for the formula r according to example 1a, then I'm going to highlight the r. And I'm looking to see what's with the r on the same side of the r, and it's being multiplied by 2 pi. So to get r by itself, I'm going to use the opposite operation. I'm going to divide by 2 pi. On both sides. And that's it. I can't actually calculate this, so this is going to be my answer. C over 2 pi is equal to r. Okay, now it's asking us to actually find the radius of the yo-yo. So I'm going to use my formula that radius equals C over 2 pi. I'm going to take my information in red here, 32.7 feet is my circumference. So r equals the circumference, 32.7 feet, divided by 2 pi. Just a reminder that pi rounded is 3.14. So I'm actually doing 32.7 divided by 6.28. And my radius comes out to be about 5.2, my boat symbol, about 5.2 feet. In example 2a, we're told to solve for m. So I'm going to highlight m in my equation. So first I know that I have to get rid of, I highlighted the 4 with it as well for right now because they're really, that's the coefficient of the variable. They're stuck together at the moment. But I have this minus 3n that needs to go away. So if I add 3n to both sides, that cancels it on the left. On the right, I can't actually add 8 plus 3n because they're not like terms. So I'm just going to write it as 3n plus 8 or 8 plus 3n. And then my last step to get that m by itself, if I highlight it now alone, it has that times 4 with it. So to get rid of that, I'm going to divide both sides by 4. And my final answer is m equals 3n plus 8 over 4. You could divide each term, 3n by 4, and then 8 divided by 4. And if you did that, you would end up with 3/4 n, 3 divided by 4, 3/4 n, plus 8 divided by 4, which is 2. So one of these answers is totally fine. In example 2b, I highlighted the n because that's what I'm solving for. It says 4n right here. So I'm highlighting the n. I put the 3 with it again because it's the coefficient of n right now. And so next what I'm going to do is get rid of this 6p, positive 6p, by doing negative 6p to both sides. And I'm going to rewrite this, either 15 minus 6p or negative 6p plus 15 is equal to 3n. And then to get n by itself now, if I highlight the n alone at this point, we end up with a times 3 stuck with it, so we need to divide both sides by 3. So 15 minus 6p all over 3 isn't really simplified since both the 15 and the 6, you can divide them by 3, so I'm going to do that. So 15 divided by 3 is 5, and negative 6 divided by 3 is negative 2 with the p. So 5 minus 2p would be the final answer for that one. In example 2c, it asks for k, solving for k. So I highlighted my k, And if you remember from the prior sections, I like to get rid of that division first, so that denominator of 5. So I'm going to multiply both sides by 5. And that gives me k minus 2 is equal to 11j times 5 is 55j. So you can multiply and divide unlike terms, but you cannot add and subtract unlike terms. Okay, now I can highlight my k. And I'm able to get rid of that minus 2 by adding 2 to both sides. So k equals, remember j and a constant are not like terms, so I'm just going to write 55j plus 2. Okay, in example D now, it's asking us to solve for t, so I've highlighted my t. I have the r plus 4 next to it, that's being multiplied by the t. If I just divide both sides by r plus 4, that gets rid of the multiplication of r plus 4. So t ends up equaling 28 divided by r plus 4. In example E, I'm looking, I forgot to highlight one of my x's. But I'm solving for x, so I'm going to highlight my x's here. Okay, so I know I need to get my x's together. That x is being multiplied to the z, so I have to move both at the same time here. So when I move that, I'm going to subtract xz from both sides. Notice there's no like terms of xz on the left, so I'm just going to write 3x. I'm going to put my minus xz in first, and then the minus 2y, because these eventually I'm going to have to do something with that. Minus 2y, since they both have an x, equals 5. Now, they're really not together yet, but they're as close as they can get because they're unlike terms. So I'm going to just highlight this area and leave that alone for a minute, and I'm going to add 2y to both sides. And so I get 3x minus xz equals 2y plus 5. Since both the 3x and the xz contain x, I can divide out an x in front of it. And I'm left with 3 minus z. It's kind of like distributive property backwards if you think about it. If you multiply this by x for the distributive property, you'll see that you would get 3x minus xz. So I'm just taking it on the outside for a minute. So now I can, to get rid of the 3 minus z, since it's being multiplied to x, I can just divide both sides by 3 minus z. And so my final answer is x equals 2y plus 5 over 3 minus z. Okay, notice in example F we have a d on both sides, so like we did in the previous sections, we would subtract 3d from both sides to get the d's together. D minus 3d, so it's really like 1d minus 3d, is negative 2d. Some people would have avoided the negative and actually subtracted d from both sides and brought it to the right, but I'm just trying to keep things consistent for those that might have trouble. Okay, and now I can highlight my d again. There's only one this time. Well, there's actually negative 2 of them, but there's all the variables are on one side is what I mean. And so from here I can get rid of the plus 5c by subtracting 5c from both sides. I get negative 2d is equal to negative 5c minus 1, or negative 1 minus 5c. Divide both sides by negative 2. And d equals, this is kind of a mess, so I think I'm actually going to divide both sides by that negative 2. Negative 5 divided by negative 2 is positive 5 over 2c. And then negative 1 divided by negative 2 is positive 1/2.